Okay, it is time for our final panel of the day. Last but definitely not least, transmission planning. Again, from right to left, we have David Mercado from Centerpoint, Prabhan Yanam from ERCOT, Kevin Sherd from NERC, Hirsch Naik from Encore, and David Penny from Texas RE, Director of Reliability Services, will be today's moderator.
All right, just a couple of quick opening remarks. In our earlier sessions today, we talked a lot about large load, the ever-increasing queue of large load interconnections that are being requested, and we also talked at length about the inverter-based resources, the interconnection queue there, as well as the other evolving technologies that are being added to the grid. So with this panel discussion, we're going to try to close the loop and basically look at the transmission planning, the infrastructure that's going to be necessary to support all that load, all that generation, and the ability to move power around as we need to around the state. So it's truly a pleasure for me to be able to moderate this panel. We've got a very distinguished group of experts here, well over 100 plus years of experience here on the stage with me. So we got a highly knowledgeable group, so it's going to be a pleasure leading this discussion today. So to get it kicked off, we're going to start off with basically an overview of what y'all think the challenges affecting transmission planners in this evolving grid that we're seeing, and some of your thoughts on activities and things that we can address them. So I'm going to start off with Kevin, so he can kind of give us the NERC level perspective on this.
Sure. I'm going to start by saying back in 1996, when I landed my first job at Dayton Power and Light, I told my college advisor that I was going to be in the energy industry, and he said, "Oh, good, that's a nice, stable industry. You will enjoy that. You'll do fine in that. That's nice and stable." That was the year of FERC Order 888 and open access, and change has been a constant ever since then. And early in my career, I was trained on load forecasting in the operations space, next day load forecasting. And, that typically involved looking at the temperature forecast, day of the week, and maybe a few other things, but relatively simplistic. One day I was really excited. I told my supervisor I had missed the peak load by 1 megawatt. And he told me, "What? You missed by 1,000,000 watts. I'm so ashamed of you." But obviously that has gotten so much more complex, and that's going to be one of the themes that I want to highlight. You heard it in some of the panels earlier today, the complexity. You start adding in, load forecasting. Now you start adding in what's the wind forecast, what's the wind speed at particular locations, and what's the cloud cover, and when sunrise and sunset, and now we're talking about things like grid forming technologies and inertia and other things that were not part of the conversation 10, 15, 20 years ago. And our studies have been evolving and have to continue to evolve, right? So one example would be the Interregional Transmission Capability Study, looking at a broader set of hours over the interconnected North American grid, broad study area, broad set of hours, rather than just some of the more at-risk, typically at-risk summer peak hours. So that's just an example, and there's lots of other studies that we need to do that need to be part of the equation. It's a preliminary report. It was referenced earlier about the Iberian Peninsula. And what strikes me most, at least based on the preliminary results, is the operators identified particular conditions and took defined actions to remedy those conditions. Those were contained in procedures. They took the right actions, or so they thought. And then all of a sudden, it wasn't the right action. They were unknowingly in an insecure state, and we see the results. And that's how, as we think about the future of transmission planning, how do we capture a broader range of the operating conditions, a broader range of the types of concerns that face the grid so that we can set up for reliability.
Prabhu, to give us ERCOT's perspective.
Yeah, thank you, David. Thank you, everyone, for staying. I know it's the last panel, so it gets harder and harder with all this information overload, so thank you. I'm glad to be here. So I'm going to just start with, I know the topic is evolving grid, just a little bit of history. Probably you all heard that, if you know this, but back when the time, 1982 or 1882 is when this first power plant was built. The primary goal of the power system is to move large amount of power, build those big plants, and move to the load centers. That was the fundamental, and that's how we started building the grid. And over the years, a lot of things changed. You heard all those changes. So we got very efficient in doing that, like moving large amount of power to where it's needed, using a transmission system which was very efficient, was working well. And then all this started, the changes you all heard started happening in the grid. So we had this change on the resource side, whether it's like deregulation driving the changes, the resource mix changing, some of the inverter-based resources. There was huge penetration of inverter-based resources. All those things posed a significant challenge, and we've been working on that for more than a decade now to address those challenges. Because we're moving from a grid where we had things were very predictable, we were very efficient in operating the grid, to changes to the resource side where things are constantly changing. So we adapted to the change. That happened both on the grid side and also taking advantage of some of the capabilities these technologies bring to the grid. Right. So it was working together. We addressed that, and now we are shifting to a different challenges where you're seeing some of the changes on the load side, especially the large loads. You heard in different panels. Of course, so all those things takes time, right? So we're going to talk some of those challenges later, but we're rapidly moving, especially if I want to talk about ERCOT more than any other footprint within North America. We're adapting or moving to this change in a pace which is unprecedented, I would say. So that's reflected in some of the things you heard. Recently we're looking at load forecast in our ERCOT footprint. We have 85 gigawatts of peak, which is, if you look at the planning cycle, a little bit going back, and if you look back 2 years back, our planning cycle, we were predicting 120, 130 gigawatts of load growth, looking at 6 years out. And then 2024, we planned the system for over 150 gigawatts. This is, to put that in context, if you talk to anybody else, how do you plan a system where you're saying okay, the load is going to double in 6 years? That's the kind of challenge we're facing. So I think there are several challenges because the grid is evolving, and the way we produce and consume power is changing. And with all that comes, a lot of we need to work on all aspects of the grid. It's not just transmission, it's the resources, and now it's more than anything the large loads. We need to take advantage of some of the capabilities they bring, and how do you make this grid work in this paradigm? That's the challenge.
Well, thank you. David or Harsh, do you have anything?
I would add that influx of large loads is significant in ERCOT. Just for context, Oncor's peak load is 30,000 megawatts, but then if you look at our interconnection queue, a couple months ago was at 140,000 megawatts, and 120 of that is data centers. So it's a significant challenge that we are trying to tackle. I'll mention that we are already on our way in addressing that challenge, and that's the 75 kV Prabhu mentioned that was coming out of Permian Basin Plan.
Mm-hmm.
Yeah, I mean, one of the key challenges is a topic that we've discussed throughout the day today about large loads. Our system is evolving. If we're going to be able to serve twice the amount of load within 10 years here in ERCOT, assuming there's generation to serve the load, the next challenge is how do you bring that power into the load centers where these large loads are going to be at. So that's kind of a challenge that we're seeing, especially in the Houston area where CenterPoint Energy is the transmission service provider. One of the unique things about the Houston area is we're on the edge of the ERCOT system. We're bounded on the east side by the Gulf, On the northeast side, we're bounded by MISO, which is not part of ERCOT grid. So we're kind of like a peninsula in the ERCOT system. So we really depend on our transmission lines to be able to import power onto the grid to the north and into the south of Houston area. Houston is a very small footprint geographically in comparison to the rest of ERCOT, but we're about a quarter of the load of the entire ERCOT system in a relatively small footprint. Unfortunately, we don't have sufficient generation capacity within our footprint, the native generation within our service area to serve the load. So we're highly dependent on transmission imports to be able to serve the demand. So as we start seeing more and more large loads interconnecting, we're going to be more and more heavily dependent on our transmission lines. So this is kind of where 765 kV could be a great solution to be able to serve the load within our footprint.
Thank you for that. I guess switch the topic slightly, but as everybody's aware, the Public Utility Commission approved the phase one of the STEP plan, the 765 infrastructure back in May. And that's obviously a new technology for many ERCOT stakeholders, and it gives us a lot of opportunities, but it also comes with certain challenges we have to overcome because of the new technology, mainly voltage control, reactive control, Ferroni effects. Protective relay systems become much more complex for protecting that level of voltage class. And the list goes on and on. So I wanted to hear y'all's perspective on any challenges that you see in the planning process to implement 765 and what your thoughts are of how we can overcome them. And I guess, David, I'll start with you.
Sure. Just to state the obvious, key benefits of 765 is the additional thermal capacity that it affords, the ability to bring more power into the load centers. But with that also comes some additional challenges. Dave, you kind of referred to voltage control. I think that's going to be a key challenge to make sure that our transmission planners really understand what are the voltage control impacts with these new extra high voltage transmission lines that we're going to be start building here in the ERCOT system. Our planners need to really understand the behavior of what the flows are going to be on those transmission lines. Kind of tying back to what Kevin mentioned about the Iberian Peninsula blackout. Part of the issue was the voltage oscillations that they were seeing and having them follow their operating procedures and closing in transmission lines that were de-energized to damp those oscillations. But as they closed those transmission lines, those were lines that were lightly loaded and created over voltage issues. So making sure that we understand what the behavior is on those new transmission lines. If a line is below its surge impedance loading level, it's going to be lightly loaded, then you need to make sure we have the ability to control voltage. You're going to have high voltage on the receiving end. Conversely, if those lines end up being very highly loaded above its surge impedance loading levels, then you may see low voltage on the receiving end. So as our transmission planners begin to design, engineer the new 765 kV build out, it's going to be very important to understand what those voltage control impacts are going to be. Installing shunt reactors along the line, evaluating whether it's necessary to install dynamic reactive support devices, SVCs and STATCOMs. I think that all that needs to be part of the overall solution. Another challenge that we've seen with 765 kV and doing research with the vendors and manufacturers as we're starting to research how we go forward with procuring materials and designing 765 kV, we've noticed that a lot of the equipment, transformers and breakers are single phase type equipment, high-speed reclosing devices, so understanding the protection settings and also how to model the different type of contingencies, not just steady state contingencies, but also dynamic contingencies to be able to capture those new type of technologies that our transmission planners honestly aren't very used to at the moment. So how we're overcoming those challenges, research, working with our peers that are starting to get experience with it. We do have a utility here in the ERCOT system that has experience with 765 kV outside of the ERCOT system, that's AEP. So we've been coordinating very closely with them, making sure that we learn from their lessons learned outside of the ERCOT grid and apply those as we're starting to design and engineer 765 kV infrastructure here within the ERCOT system.
Thank you. Our sense that a lot of the initial infrastructure is going to be an on-course service area. I'd love to hear your perspective
Yes,
on this
certainly.
as well.
I'll start with saying that there are a lot more benefits to 765 kV than challenges, but certainly there are some challenges we are working with. Voltage control is a big one that David already covered. If I were to mention a couple others, one of them is short circuit current levels. We are seeing that near the 765 kV lines, the stations nearby are seeing increased amount of fault duty. So we are having to look at the protection systems, looking at the breaker ratings to make sure that we either upgrade the breakers or upgrade the stations so that they can handle the increased fault duty. Another challenge is that if you look at what was approved in the Permian Basin Plan, it's essentially 1,200 miles of 765 kV line, but it's essentially 3 radial lines. Each of them is roughly 400 miles, and 2 of the lines have a midpoint in the middle of the line, but the other line is just straight shot. The challenge with having a radial configuration, now let me be clear, that's a great start, and that's what serves the Permian Basin, and that's what we need today. But thinking out future, thinking out long-term, thinking about serving all these large loads, we have to think about how do we start networking these lines, whether that's closing the western loop or building out the rest of the eastern connections so that we have a stronger backbone. And this is a great investment opportunity, but it's also an investment into the reliability and economic growth of Texas.
Thank you. Prabu?
Yeah. Yeah, I guess, when we started like looking at the 765 versus 345, there was a lot of discussions. You can find those information, at the PUC and other forums we have shared. So we did identify that, yes, with this growth, projected load growth and the, associated uncertainty with the generation, because there's also the big part, like, you need to know where this future generation is going to, show up in the system to serve this load. So with all those considerations, we did arrive at like the 765 or the 765 step plan, which Harsh talked about, which is eventually having a network of 765 kV lines is the right, investment for Texas to go, build up the grid to serve the future needs. So one part, like Harsh said, we have these lines already approved for Permian, and we are looking at, as part of our current annual planning process and other TSP studies, we're looking at how can you, build other parts of the system so that we can get a network 765 kV line. And if you look at it, the transition is always, obviously there's a lot to learn because we are switching from a 345 kV that came in like 65 years ago. So we are relied on this 345 kV, and now we're moving to 765. But the good thing is this technology is not new. There are other parts of the country or world they have had this for many, many years. So like David said, we have to learn from some of those, people who have been operating the system for a long time. And we are doing that. So we're working with like AEP, and we are reaching out to, others like the Hydro-Quebec. They have had like a 735 kV system for like over 40 years. Mm-hmm. So we need to, obviously there will be some challenges, but some of the benefits of 765, it's not only the transfer capability, but it's the overall system strength issues. Like, you're getting a stronger grid when you're trying to connect all these loads and generation, which, is going to be helping us. And it's not just ERCOT, everybody else is looking at 765. Probably I'll let Kevin comment on MISO plant, MISO, SPP, and others are also. So this helps the technology and the manufacturers focus on those supply chain issues and manufacturing those 765. So it's a step in a good direction.
I'd be curious to get your perspective as well from ERCOT's level, if you feel like our existing planning processes are adequate to cover what's necessary at 765, or do we need to evolve and look at more, specialized EMT type studies and things like that?
I think I would say anytime we are changing the system to a new technology, there's a lot we're going to learn and study. So obviously, yes, we need to look at all those things closely. We've learned from building building different parts of the system, including the 345 press. There are a lot more challenges and studies that needs to happen when you're transitioning to 765 or new technology in general. So we are looking at it. We are working with the TSPs to do that. So that's why you see much more emphasis on when you're trying to connect the large loads and generators. We are putting more emphasis on stability studies and looking at conditions which we typically don't study in the past. It's like looking at summer peak conditions. Now the net peak conditions are driving some of the issues, and we need to. Yes, there's planning is always evolving, and we are trying to adapt and change the way we do planning. And there are some discussions happening at the stakeholder level and coming out of the legislative session too. So we're working with all of them, like, the legislators, the PUC, and the transmission team, or transmission planners, to see what's the best way to adopt our planning. Because it's, even the challenges, when you look at moving from a radial 345 to a network 345, we use the current existing process, but there are some challenges there because those processes were set up to look at individual projects. Sometimes when you're looking at big regional projects with bigger benefits, obviously there are different things you need to look.
Thank you. Kevin?
I totally agree with the comment that was the benefits of 765 outweigh the challenges, but certainly there will be some new challenges, and one of them I would just like to emphasize a little bit is that those light load studies. Light load studies typically don't get a whole lot of attention in the planning realm, and suddenly those become ultra critical because you have to have sufficient reactive resources to control voltages when there's so much more reactive potential on the line. Another advantage is the system strength. You were talking about that resilience. Also lower losses. You can transmit much higher levels of power with lower real power losses, and that's a real benefit. That's a megawatt that doesn't have to be generated if it's not lost. So that's really good. The other thing to watch for in the planning studies and operational studies is your contingencies just became larger. Right, a 765 kV line can easily have 2,000-3,000 megawatts on it. Well, that's got to redistribute if something happens to that line, and the underlying grid has to be ready to handle that, or some sort of remedial action ready to deal with that contingency. So the contingencies become larger, especially under like a prior outage scenario too, where the underlying grid may have one or more elements removed. Being ready for those large contingencies is important to study.
Yeah, that's an interesting point because there's already discussions going on in the protection group with the relay folks around using single pole tripping, for example, at 765, and that drastically changes the contingencies that you're alluding to. So go ahead.
Yeah, so something I would like to add, I know we talk about 765, yes, we're going to build, or we propose 765, but if you look at the plan from ERCOT, it's 765 and upgrades to 345, right, and new 345. So people, we get excited about 765, but that's part of the transmission build out. But it's critically important is like to keep this 345 and enhance and build, and some of the upgrades you need that goes along with the 765.
Right. Thank you. Again, shifting gears a little bit to talk about large loads, and I know it's been subject of several topics this morning brought up about the integration of large loads, the accuracy of the models, the ride-through issues, and so forth. So I want to get y'all's perspective from a transmission planning perspective of what y'all see is, I guess, start off with how do you determine which large loads we need to incorporate into the future load flow planning cases, and what the best ways of addressing that is, because it is very obviously nebulous at this point in time. Senate Bill 6 is going to give us some clarity around that, but I want to hear y'all's thoughts. I guess, Harsh, we can start with you.
Certainly, that's something we think about quite often, given our long interconnection queue. So if I rewind back to before 2023, ERCOT did not have the ability to study prospective loads that do not have signed interconnection agreement with the utility. So that always left us scrambling, trying to catch up with the load because they could come online much faster than transmission can get built. That changed in 2023 when House Bill 5066 passed. That allowed ERCOT the ability to include prospective loads. But then the question was, okay, we have many prospective loads, talked about an Oncor queue. Which loads do you include of those prospective loads? So that's where Oncor sponsored a nodal protocol revision request to modify the ERCOT protocols. And essentially what it did was it created definition of substantiated loads that ERCOT will study. And it put loads in three buckets. One is obviously the loads that have signed interconnection agreement. Second bucket was loads that had a third-party study validating the need for the demand. And a great example of that is the Permian Basin study. That it's based on a third-party consultant study that looked at the minerals in the ground and converted that into electrical demand. So that's an example of that. And then the third bucket was the loads that are not signed. And what we did there was the language states that if an officer of the company has a high confidence in the loads, then they can put those in the planning models. So then that led us, or every TSP, to sort of think about what's their criteria for high confidence loads. For Oncor, what that has meant was we have obviously make sure we have the right load ramp and the load questionnaire that has all the details about the load consumption, what's the load factor, what's the power factor, what do they plan to build, how do they plan to operate, what are their equipment. Beyond that, we also started asking for CMLD load models before we can account for them. Because as we heard this morning, it's very important to look at these loads and how they behave dynamically. But then going beyond those, we would also ask questions like, do they have site control? Do they have test fits? Do they have KML, KMZ files we can take a look at? And all of that goes into forming what we call high confidence loads. And all TSPs did that differently. So now fast forward to 2025, and we have Senate Bill 6. Senate Bill 6 now will require the commission to develop rules around sort of coming up with a similar type of criteria that all TSPs can apply, and so that we are all consistent. And it's asking to consider similar things. It will have impact study fees. It will ask for security based on per megawatt. And then it will ask to make sure that the customer does not have duplicate requests within ERCOT, because that's a big problem we are seeing, that they're shopping around all over the state. So I think SB 6 will feed into the commission rulemaking into the next year, and then hopefully that will eventually make its way into the protocols and planning guide.
David, do you have?
Yeah, the whole process to introduce prospective loads into the ERCOT, RTP cases, I think was a great step in the right direction. But obviously there's a balance. You don't want to have too much prospective load that your case isn't solved. You don't have enough generation to solve. You want to kind of be realistic. So I think the processes that we have in place, I think, are a step in the right direction. Harsh mentioned the ability to have officers attest to loads, and also have third-party studies to be able to do those load projections based on economics and development that are in your service area. And CenterPoint Energy leveraged both of those to be able to include additional prospective load in the ERCOT load forecast. However, I still think there's an opportunity to standardize the way utilities make those decisions. Oncor, CenterPoint, AEP, others may have the same processes, but maybe not the exact same requirements on what a prospective load is that has some high likelihood of and high confidence level of occurring. So I think Senate Bill 6 will help with some of that standardization. CenterPoint, for example, in the most recent ERCOT load projections included 10 gigawatts of load by 2031. So we were actually a little bit more on the conservative side than maybe other utilities. So I do think there's an opportunity there to have some standardization. Some of the processes that are currently in place, I think, are going to help with that.
I think they covered most of the stuff on the load forecast. So we are going to work, with the stakeholders and the commission to see, what comes out of the Senate Bill 6 and the rulemaking. That'll help us, standardize or the future planning cases, or what the loads that go into the future planning cases. So I guess, the loads are, we're talking about the loads, but I think there are other technical challenges too. One thing is to say, okay, we want to add X amount of megawatts of load in certain area. We are finding recently there are other challenges, that could also have an impact on, how much you can accommodate in certain parts of the system.
I guess, Kevin, I'd like to get your perspective on this. I'm curious what other areas of the country are doing as far as some of the more subjective type loads that they're including in the planning cases and how they're potentially addressing it.
I think I would summarize that with inconsistently. And that's also true on the generating resource side as well. We've got at NERC, we've got some tier levels, tier 1, tier 2, tier 3 for relative certainty of new generating resources. But what we saw, especially in the ITCS, was the application of those criteria do vary widely. And we saw, and some of it's just timing, but differences between submissions into the long-term reliability assessment and individual state IRPs. Like I said, some of it's timing, some of it's data. there's opportunities to be more consistent.
Okay. I guess the second part of the large load discussion, and Arch, you talked about it with the CMLD models, is obviously the voltage ride-through concerns that we've had. So I guess I'm curious on how you guys as transmission planners are addressing the need to get not only those types of models, but accurate representations of how those resources are performed so that we can do the types of specialized studies, like Prabu mentioned, if you have a large concentration of data centers in a localized area, how do you look at frequency and voltage concerns if that load decides to trip off? So I guess, Harsh, if you want, I'll let you start.
Yeah, no, I can expand on that. So it's a struggle right now because we are asking for CMLD load models, and for a long time, customers were very hesitant in providing that because we heard this morning when they're submitting the load application, they don't even know who's going to use that facility, right? So it's been a struggle. At some point, we drew the line and said we have to have CMLD load model. The challenge today is we have a model, but we don't know if it's accurately representing what will be built. So how do you circumvent that challenge? In our studies, we'll conduct the studies, everything looks great, but then if you have a real-time event, then the load may trip, or it would behave in a way that we did not foresee. So that's a challenge, but that's where I'll say that ERCOT's sort of leading the way. ERCOT recently, last week, or over the last several months rather, they have put out a DWG, which is an ERCOT working group, has put out a load survey of 60 questions that's asking all kinds of questions to the load in terms of how they're going to behave, what kind of equipment they're putting in, what's the load factor, what are their ride-through settings, what are their protection settings. I think that's a great step forward in trying to understand how they will behave, and then we can use that to see what's in the CMLD load model and align those to make sure that the studies we're conducting are correct. Another improvement we will soon see is just last week, ERCOT did put out their thoughts on what ride-through capability requirements may look like in ERCOT, where each load will have to make sure that they can meet that requirement. So I think that will be a great step forward because I think we have all heard about different events where multiple loads was lost as a result of a contingency. And a lot of this has to do with obviously ride-through capability, but also needing to understand protection settings. There's a lot of discussion around the Dominion Energy having a load loss event where it tripped a certain amount of load, but if you go look at the report, it's clear that the load was able to ride through the initial fault, but when the TSP's protection settings tried to close the line second time and then third time is when the load stripped out. So that was purely a function of not having or intentionally having a certain protection setting to save their equipment. So if we can somehow make sure we are coordinating this protection settings and all aspects of loads with the utility protection settings, I think that'll go far away.
Thank you. David?
Yeah, no, I echo everything Harsh mentioned. I think it's important to understand the behavior from a load model perspective of these large loads. Unfortunately, we're kind of at the mercy, from a transmission planning perspective, at the mercy of the data that the loads provide us. So it's great to hear that there's currently efforts between ERCOT, transmission planning organizations, and large loads to be able to collect that data. One of the things I will like to highlight is there could be stability phenomena that aren't necessarily captured in the load models. In the Houston area, we've seen large loads trip offline due to harmonics, which is kind of outside of the typical planning type study. It's more of an EMTP type study. So that's something I think we need to be mindful of as well. The other aspect I think it's important to highlight is that these large loads can have reliability impact once they trip offline. So understanding their under frequency ride-through capabilities and under voltage ride-through capabilities, I think that's a quick, easy thing as long as we can get that data from the customers. CenterPoint Energy has a large amount of large loads, historically industrial loads from petrochem facilities to refineries to natural gas compressor stations to liquefied natural gas facilities being in the Port of Houston, the Ship Channel area. It's something that we're very familiar with, but some of these large data center loads, crypto mining loads, it's really new to us. So understanding those load model characteristics is going to be really important.
Prabu?
Yeah, I guess I echo with everything they said, but my thinking is, in the absence of getting those detailed models, you'll be in a position to make some conservative assumptions, and that could hurt the interconnection process too. So my earlier point is when we try to find a solution for this large load growth or evolving grid, it's all of the above. It's transmission is going to play a part, and the capabilities of the load, what they bring, and how we can leverage those technologies to interconnect large loads and operate those loads is also important. In order to do that, we have learned from all the IBR issues we have had, the modeling and capturing those settings. Either one thing to get the models, and then also validate and verify the models is equally important. So we are already finding out like some of the large load issues. These are all like inverter-based loads, majority of them. So there could be similar issues like what we've learned from the IBR issues. So we have to, it's absolutely important to understand those load models and accurately model them in the study. So we're not, making conservative assumptions which could, have a negative impact, like curtailing the loads and those kind of things. So,
Thank you. Kevin, I guess I'd like to get your perspective from NERC level on load
Yeah,
modeling. What's going on?
I've got a message of hope and a message of caution. The message of hope is large loads aren't new to the industry. We've been dealing with a variety of arc furnaces and metal refineries, et cetera, many of which are non-conforming, and they switch on and off hundreds of megawatts at a time. Those have been solved through active communication between load and customer and utility, and it wasn't a one-time conversation, right? I know of examples from a utility I used to work for. A load was added for a car parts manufacturing facility, and system reinforcements, including capacitor banks, were added, and suddenly the customer was having voltage transient issues whenever the operators would open and close those capacitor banks. And so, in one of the cases, we worked out a timing schedule of close the capacitor bank at such and such a time and open it up, at such and such a shift change. And we could set a timer that would do that for us. And that was the solution in that instance. In another instance, we actually went back and resized one 90 MVAR capacitor bank into two 60 MVAR capacity banks so that the voltage delta was reduced to not impact the processes that were going on. So the word of caution is, with the larger scale of loads, there is certainly higher system risk if we don't get it right. So we need to have the conversations. We need to continue the conversations. Maybe the model isn't exactly right on the first pass, and through nobody's fault. We just learned more. I mean, who would have been thinking about the reclosing settings? I mean, in the transmission planning process, who would think about that? Oh, but here's a lesson learned that, yeah, it wasn't the first shot, it wasn't the second shot, it was the third attempt. And there's a setting to, okay, well, the grid's unstable right now, I'm gonna get off. So that dialogue is very important. And then, to the extent that there's opportunity for guidelines and standardization, there's task forces looking at that as well.
I guess a shameless plug on this topic, because I'm currently working with ERCOT staff as well as some NERC staff. You mentioned the Dominion event, but we're working on a similar type of review of some of the low loss events here in ERCOT, focusing on the Bitcoin crypto miner type facilities. And some of the things that are coming out of that are very interesting, because those types of facilities do not have backup generation, do not have UPS systems, so their performance is very different. And you're alluding to relay protection system issues, and that's kind of what we're uncovering. If they have part of their load trip off due to a single line of ground fault, they have, in some cases, neutral overcurrents relays in the plant that are tripping off their whole facility, and other things going on, and all that'll come out when the report's finally published. We're currently working on that, but it's interesting some of the things we're uncovering, because the Bitcoin crypto miners are very different from a traditional data center, and so we have to be cognizant of all those little differences. I guess the last question I had is, again, we talked this morning about some of the things that are happening on the resource adequacy side, about how we have traditionally looked at resource adequacy from a deterministic approach, looking at summer peak. Now we're evolving to a 24/7 energy assessment. As the grid evolves, what do we need to look at from a transmission planning perspective? Do our transmission planning assessments need to evolve from the traditional TPL studies to look at other things that maybe, that are going to happen due to the evolving grid? I guess so. Prabhu, we'll start with you.
Yes, the answer is
Difficult topic.
So, if you look at ERCOT, we've been working on that, even before this change. Over the years, we have had a lot of ERCOT-specific things, criterias, and other things that came out from stakeholders, from legislators. We're already doing, like, we have been doing, like, not reliability planning, but economic planning too. So we're using the economic models to run 8760, look at system congestion and see whether we can propose transmission projects. That has evolved. The criterias have been, there's been some changes as recently as like a couple of years. We worked with the PUC and legislators to put a new criteria, looking more focused on looking at congestion costs from a customer perspective, and see whether we could, build transmission projects to relieve those congestion, economic projects. So in addition to that, we have also started looking at the grid resiliency aspect of the grid. So there was a new criteria adopted recently. We finished our first biannual study last year, 2024, which focuses on the resiliency of the grid, looking at extreme weather events and like some things like cold events, hurricanes, and those kind of things, and see whether there are projects which we can. And we're also looking at other things, changes, like how do you combine all those things and see, like, get a value using a multi-value project, like looking at grid resiliency, reliability, and the economic criteria as a whole and propose projects. So the answer is yes, the grid is changing. We have, even before that, we have started doing all those things, but now like I said, when my opening remark is, it's not just the resources which are changing or intermittent resources. Now majority, or like big portion of the load is going to vary in a matter of minutes, if not seconds. So you need to build a grid. You need to look at, you can't just look at system peak condition and say, like, yeah, everything's going to be okay. So also to add, like, how these loads are going to be, most of the loads are like, some of them could be like controllable load resources, and they could be like, price sensitive load resources. So all those things, is going to open up like a lot more, window of looking. I'm not saying you have to do an 8760 reliability analysis, but you need to be expanding your planning analysis beyond your typical summer peak, winter peak, and off-peak conditions, because there are going to be, grid conditions, which is not only just like the peak conditions, but looking at, maintenance outage windows. That's going to be a big challenge if you're relying on approving maintenances based on either like intermittent resources, IBRs, or you're like, taking advantage of some of the, like the load controllable loads. Then you need to see whether you have, like, the grid is capable of, like, performing under those conditions. So all those things needs to be done. And you see there's a lot of discussions, even people are looking like probabilistic analysis to incorporate some of those variabilities. So all those things are getting, greater focus and importance now than ever. So we have to be on top of things, yes.
Yeah, I see the biggest struggle of looking at all those different types of scenarios you look at that we traditionally have not done in the planning horizon, especially depending on where where you shift your generation resources at any point in time, moving that around, and the amount of time it's going to take to develop those cases, I think is definitely going to be difficult.
And I'll just add one more thing. So there is also this uncertainty of what future resources we're going to get to the grid, right? Yeah. So that's going to drive, how all this, what conditions you're going to study. If it is like now, it's predominantly what you have ERCOT is like, the solar and batteries. If that changes, that's going to change the way you look planning too. So there's a lot of moving parts here.
Kevin?
Couple things, agreeing with everything that's said, a couple things I would add. One, that TPL 8 standard, I think it's important, not necessarily to mitigate every single possible risk, because at some point that becomes a affordability concern, but communicating, exposing, and having the transparency and agreement on the level of acceptable risk for the conditions that are beyond a typical summer peak or beyond a typical winter peak, so that there can be agreement and fewer surprises when those types of conditions occur. As Jim said this morning, that the weather events are becoming more severe, more frequent, and affecting a broader area. And maybe this is a little less applicable to Texas with its own grid, own interconnection. But in many areas, the study was, okay, I'll look at my area, and then when it comes to external assistance, the last few events, I've gotten 1,000 megawatts from my neighbors. I'll plug that into the mix. Well, one, the neighbors' resource mix has changed since those events. They may not have that surplus to share with you at the time. And two, they may now be having the same type of event, be it hot weather or low wind or extreme cold or whatever the case may be at the same time you are. And so having a broader view of what's going on, not just in your own area, but in the areas around, to see where assistance can be available, and avoiding over-reliance on a system that's not going to be there, but also exploring opportunities to make or strengthen connections that may be of help in some of these extreme conditions.
Thank you. David?
Yeah, just remembering when I first started in the industry almost 25 years ago, summer peak was really the tightest grid condition between 3 p.m., 6 p.m. That was where we were concerned about. That's no longer the case. Just watching the physical response and capability numbers on the ERCOT website, this summer, you see a huge margin at the peak hour of the day because of all the solar generation that's available. The concern now is, as that solar starts ramping down in the evening hours, you got that 20,000 plus megawatts disappear within a span of a couple hours. That's going to be your tightest grid condition. So as it's probably mentioned, running net load studies is going to be important. Having various sensitivity analysis in your planning assessments. I think, Kevin, you had mentioned doing light load studies. That's something we typically don't put a lot of attention to, but that's going to be important, especially as we start building out our 765 kV system. So, one of the things that's key is to make sure that we assess all these planning scenarios. But I think the challenge is, do we have the resources to do all these sensitivity scenarios, all these studies? I think it was Michael Weber mentioned there's like 1,000 grid modelers that are needed right now. So having transmission planners and the resources to perform all these studies, I think it's going to be one of the immediate challenges. So trying to identify the priorities, which scenarios should we focus on, is going to be important. We talked a little bit about AI today. Could we use AI to help run some of these studies, not necessarily to replace our planners, but to augment the work? I think it's something that may be valuable looking into as well.
Harsh?
No, I'll add the same points there. If you look at ERCOT's interconnection queue today on the generation side, it's mostly solar or batteries or a combination of both. And like David mentioned, in summer peak, we are doing fine now with all the solar that we have added over the last several years. And after sun goes down, batteries that's offsetting that demand. But now we have to start thinking about if we are adding. So today, ERCOT is whether the overall load is weather sensitive. So you see the peak and then the load goes down and you're fine. But what happens when you add 30,000 megawatts of load that's 24/7 and that's flat? So your power flow will look significantly different when you have no solar and when you have no batteries. And obviously the question is, where does that generation come from? But even if you find that answer, that flow is going to be different. It's not going to look exactly how the peak will look like. So I think eventually we need to start thinking about how do we plan for different power flows that will happen because of the changing resource mix.
Thank you. I think that was the last of the questions I have, Thad. Do we have any questions coming from the audience? Not a question, but a FYI.
Great.
Yes.
Thanks.
Yes. I know the PUC is planning several workshops on SB6 over the coming weeks, and that the first one is next week. So, yeah, thank you for that.
I like those kind of questions.
Yeah. Easy. Do you agree that 765 lines must be kept as superhighways and not allowed for any load or generator connections? Prabhu, I'll let you chime in.
Yeah, I think that's, that question was raised earlier when we had a discussion between 765 and 345. I'll answer it this way, right? So 765, the purpose of the 765, the way we designed is, like we said, yes, we see a need to build this, higher voltage EHV transmission system because of the projection in loads, the uncertainty in generation, the flexibility you need to move large amount of power between areas, and some of the other issues like, yes, there is variability in this kind of resources you have, day and night, solar, no solar conditions. All those things prompted us to look at and say, like, yeah, we need a system where we can move like large amount of power across the system where the load and projected generation sources are going to be. So we proposed the 765. And then the question becomes is like, hey, what do you have? Like if you have like different load generator, I think, it's up to the, I'm going to let there's nothing in the protocol or anything in ERCOT which says like you can't connect to those, right? But obviously, I don't know whether economically makes sense because it's like a higher cost to connect to a 765 versus 345, right? But one thing I would say is, as we look at the system, we built the 765, eventually get the 765 kV network. What that's going to do is it's going to create some capacity on the 345 kV. It's going to relieve some of those transfers and flows. So, in a way, it's going to help, get you some kind of, margins in a 345 kV in another system, underlying system, so you can connect more resources there too.
Do we know the extent that where 765 is prevalent in other areas of the country? Do they allow direct connection of loads, for example, to those
Open
lines?
access says if you want to
Yeah.
connect, you can connect, and the 765 in other areas of the country, one of its primary purpose was to connect large generators to, cities and other large load centers. But I agree with Prabhu's comments that the interconnection cost is going to naturally be higher. Trying to interconnect at 765 kV, it's not going to make sense for most folks wanting to interconnect to do so at the 765 kV level, unless it's very large.
I guess for CenterPoint and Encore's perspective, do y'all foresee allowing, in your interconnect agreements, allowing loads or generators to direct connect to
I'll
those
start and
facilities?
say that we hope we never get there where we have to connect a 100 megawatt battery onto 765 kV. But at the same rate, I do think about what happens when you have 4,000, 5,000 megawatts of campus at a single site once in interconnection. How do you serve that, right? And I don't have an answer today, but those are the things we'll be looking at. And that's not a random number, by the way. Those are actually interconnections that we have in our ERCOT system today. So that's the reality. So I think we'll have to address that question someday in the future.
Okay.
But certainly, connecting smaller 100, 200, 500 megawatts of load or generator makes no sense.
Not gonna happen. Dave?
Yeah, I think about 10 years ago, we're probably asking the question it's the same question on 345 kV. I think now CenterPoint has adopted and gotten kind of comfortable with having loads connected to 345 kV. But the root issue is we want to maintain the reliability of this. We call it a superhighway. So do you want to put a customer on this key transmission line that could potentially interrupt flow and cause potential downstream cascading impacts? I think as the 765 kV system is in its infancy here in ERCOT and building out, there's probably going to be some hesitancy to interconnecting loads to 765 Perhaps in the future, as the system becomes more robust and networked, there may be an opportunity. But I think as of now, if you were to ask me from a CenterPoint perspective, I would hesitate to do connections at that level at this time.
Thank you. Are there any other questions? Since reactive power is critical for proper operation of the grid and new types of generation don't provide much, are there incentives for reactive supply being considered for the ERCOT system?
That's a policy question.
Yeah, that sounds like a policy question to me. I mean, except for instances on the, at least on the transmission planning side of, I say static, dynamic reactive capability to manage voltage on the transmission system is one question, but again, dynamic capabilities associated with generators is another.
Yeah, now keep in mind, we already do synchronous condensers,
Right.
and that's a transmission asset, so
Right.
we already do that. But paying for reactive power, that's not a utility, that's
Right.
a bigger policy question.
I mean,
Yeah, agree.
if y'all have anything to add. Yeah. Given the high variability and large amount of load associated with data centers, are changes to the existing practices and requirements needed to ensure that at least 25% of the ERCOT system is equipped with UFLS? I guess, Harsh, you may be at the leading edge of this. I'm
Yeah, no.
interested to hear your thoughts.
That is something we're looking at. Traditionally speaking, we have not installed UFLS systems or protection settings on transmission customers, but as we started seeing these large loads come on transmission system and they're significant in size, that's something we're actively looking at and putting in the contracts.
Okay. So that would be,
Certainly, it changes the total amount of UFLS
100%.
needed.
right.
So how do you apportion that
Yep.
appropriately?
I guess, David, I'd be curious to hear what CenterPoint's thoughts are.
Yeah, I mean, one of the challenges is you have so much industrial load and now large load that it's becoming a larger and larger part of your overall customer base load, including residential load. So definitely don't want our residential customers to be able to be responsible for the bulk of the requirement to shed load. I think we talked about it a little bit earlier this morning, I think when Martha was talking about large loads. So I think it is something to consider. We're kind of evaluating at the moment. I don't think we made a firm commitment on if we should require industrial customers to have the ability to shed load, but I think it's something that needs further discussion.
Definitely. Okay. How do you anticipate 765 will affect black start capabilities? I don't know if y'all
I'll
have
just say
thoughts on
it's always good to have options, but 765 kV as a black start cranking path is probably pretty far down the list of desirable options, just because the voltage control is so challenging when it's lightly loaded. That voltage rise and when the system is so fragile, it would be very, very difficult to control. So that'd be pretty far down the list.
Yeah, I mean, definitely given the current state of how ERCOT's black start plan is put together, the 765 is probably going to be the last stuff energized. Agree with you. Any other questions, Thad? Recently, NERC had to agree that there were data issues in MISO's long-term assessment brought up by the MISO Independent Market Monitor. What is TRE's process to make sure that NERC has correct data for the ERCOT system? I guess I'll answer that, because the reliability assessments really fall under TRE's responsibility, and we definitely have a constant back and forth feedback with ERCOT staff. It's not really, doesn't fall into the transmission planning realm. It's more into the resource adequacy, energy availability realm that we do those types of assessments. But definitely there's a lot of checks and balances that we go back and forth with ERCOT to make sure that the generation that's being included in the queue is correct, that capacity numbers are verified several times over, and also that the tiered approach that Kevin alluded to earlier around how we put generation into tiers, tier 1, tier 2, and tier 3, that all that's accounted for properly. So I think we have a very good process for checks and balances to make sure that is accurate.
David, that was our last question, so
Okay.
thank you to you and the panel for a great discussion.
All right, and just closing comments, again, thank you. It was an honor having you guys up here. Pleasure having this session with you, and I appreciate your time. Thank you.
Thank you.
Thank
Thank
you.
you, everyone.
The workshop's not over, folks. Before you get too excited, the last part of the workshop is you filling out your survey that you'll receive very soon. This is a key part of the entire process because we get feedback from all of our stakeholders on how we're doing, on the presentation of the material, on the content that we're talking about, and even subject matter experts. So please take just a few minutes to fill out the survey when you get it. We design it to be quick and easy, but also give you an opportunity to give us direct feedback. Thank you all of you for attending, and we'll see you at the next event.